Hello everyone. So today we're going to teach acids and bases by studying it from the notes and teaching some points on the board. So basically over here we have to know these definitions, which are base, strong base, weak base, acid, strong acid, and weak acid. Base is a proton acceptor. You can remember it this way. The A over here shows that it's an acceptor. The strong base is fully or completely ionized. They have the same meaning, and weak base is partially ionized. While the acid is proton donor, you can remember it this way. D is for donor. Strong acid is fully or completely ionized, and weak acid is partially ionized. So basically base A is for acceptor, proton acceptor, and acid D is proton donor. For explaining this part, you know that the acid has H positive, and positive also always donate, so it's a donor, proton donor, and the base has OH negative, which always accept, base acceptor, acid donor. Strong is always fully or completely ionized in both acids and base. Weak acid is partially ionized. Now, alkali. Alkali is a type of soluble bases, and they are group 1 hydroxides only. So basically group 1 hydroxides are soluble, and they are called alkalis. They are bases, while the metal oxides are insoluble and they are not called alkalis. They are insoluble base. We have 4 acid reactions. Acid reactions are 4. Number 1 is the displacement. Displacement is the same as redox, which is with metals. So the first reaction with acid with metals is called displacement or redox. Number 2 is neutralization. Neutralization has 2 parts, with alkalis or with metal oxides. And number 4 is with metal carbonate. And now we have 4 types of bases. Base number 1 is metal hydroxide, base number 2 is metal oxide, base number 3 is metal carbonate, and base number 4 is ammonium salts. Now we have 4 types of indicators. Number 1 is litmus paper, and it's red in acidic solution and blue in basic solution, and litmus paper or litmus solution. Okay, methyl orange is pink in acidic environment or acidic solution, orange in neutral, and blue in basic. In thymylpethylene, it's colorless in acidic, neutral in colorless in neutral, and blue in basic. We have a tip over here as well. Anyways, in the universal indicator, which is pH, red is strong acid, weak acid is orange, neutral is green, weak base is blue, and strong acid is violet. Over here, it's an exam tip. For most of the indicators, base is blue. Base is blue. Over here, as you can see, litmus paper or solution, red, blue. Methyl orange, pink. Neutral is orange. Neutral is orange. Remember this way too. Basic is blue again. Thymylpethylene, colorless, basic. A tip for this one as well is that you do it as, for example, the rainbow or on the shades red, orange, green, then blue, violet. This is not the color. No color is correct. No shade is correct. But it's red, it's orange, it's green, it's blue, it's violet. Okay? So base is for blue. Base is blue. So basically strong acids is from 1 to 6. Neutral is 7. Weak base is 8 to 14. And here we have the 4 types of oxides, which is first one is basic oxide. It's more than 7, so from 8 to 14. For example, metal oxides, it's an insoluble base, but group 1 oxides are soluble and they react only with acids. So basically base react only with acid. Here acidic oxides, for example, non-metal dioxides, because you have to know this because we have dioxide and we have monoxide. Dioxide's pH is greater than 7, and it's mostly liquids and gases and fewer solids. They react only with bases, so basically acid reacts only with base reacts only with acid. And I'll show you this in another part right now. Neutral oxides, none. Neutral, none. Metal monoxides, for example, water, carbon monoxide, nitrogen monoxide, they neither react with acids nor bases. They have pH exactly with 7 and they are neutral. And here we have the last one, which is called amphoteric oxide. They react with both acids and bases. An example are aluminium oxide and zinc oxide. Aluminium 3 triple oxide, okay, whatever, and zinc oxide. And they both have acidic and chemical properties, and so they react with both acids and bases, and they are insoluble in water. And so basically, as you can see over here, we took 4 types of oxides. Number 1 is basic, 2 is acidic, 3 is neutral, which is the non-metal dioxides, and non-metal monoxide, sorry, and the last one is the amphoteric. So this is acid. Okay, this is acid, for example HCl, and this is alkali or base, whatever base, for example NaOH. So basically the basic reacts with acid but doesn't react with base as well. They don't react together. Base reacts with acid, the one different, but doesn't react with the one like it. Acidic reacts with the one different but doesn't react with the one like it. So acid doesn't react with acid. Acidic doesn't react with acid. Base doesn't react with basic. And vice versa, of course. Neutral doesn't react with any, and amphoteric reacts with both. I'll tell you something again over here. So we said basic, like metal oxide, acidic, like non-metal dioxide, and neutral is non-metal monoxide, and lastly amphoteric, Al2O3, and this came from the valency of Al3O2, and then the 2 goes over here with Al and 3 goes over here with O3, so making Al2O3. We're gonna teach this later in other videos. And also ZnO, zinc oxide. And so currently this is the acid. Okay, this is the pen I use for writing on the iPad, and I have an unboxing video and a review video on the channel. So basically acid with metal forms salt and hydrogen, and this is the only reaction that forms only salt and hydrogen. As you can see here, it's the only pink reaction. Over here is acid with metal oxide forming salt and water. Acid with metal hydroxide forms salt with water as well. Acetic oxide with base also forms salt and water. So the only salt and hydrogen is the pink one. Acid with metal, only metal, like metal with no oxides, okay? Acid with metal oxide, acid with metal hydroxide, acidic oxide, and base forms salt with water. Acidic metal carbonate forms salt with water with carbon dioxide. Acidic with metal hydrogen carbonate forms salt with water and carbon dioxide. So basically anything that has carbon forms carbon dioxide, carbon dioxide. So only salt and hydrogen is acid and metal. Salt with water, salt with water, salt with water is acid with metal oxide, acid with metal hydroxide, acid with oxide plus base. And lastly, the one with metal carbonate or metal hydrogen carbonate with acids form three stuff: salt, water, and carbon dioxide. This is the part I just explained over here, which says that the strong acid is from 0 to 2. The weak acid is from 3 to 6. The neutral is 7, exactly 7. The weak base is from 8 to 11, and the strong base is from 12 to 14. Example of strong acid is sulfuric acid or hydrochloric acid, which is HCl, or nitric acid. The example of weak acid, which is partially ionized, is carbonic, vinegar, or organic acids. The 7, which is exactly neutral, are, for example, water, ethanol, alcohol, salts, or carbon monoxide or nitrogen monoxide as well. Over here is strong bases. Examples are potassium hydroxide. Potassium hydroxide is group 1 oxide, hydroxide, or sodium hydroxide, because group 1 and 2 hydroxides are strong bases. However, group 1 is stronger. Now acids, for example, carbonic acid, which is, look at over here, every acid should have hydrogen. Okay, carbonic acid, hydrochloric acid, nitric acid, phosphoric acid, and sulfuric acid are these acids. I think that you should know them. This is very common. Nitric acid is as well as just you put nitrate and then nitrate and hydrogen, and here carbonic acid, you put the carbon. Here carbonic only without acid is CO3. Carbonic without acid is CO3, 2 negative. And so when you put H, which is positive 1, and CO3, which is 2 negative, and then you switch them, the 2 negative comes over here with H, and then you don't put it up, you put it down, and then CO3 with positive 1 comes also down, and then because it's only 1, we don't write it, so it's H2CO3, as you can see. You can see over here, it's H2CO3. Phosphoric acid is same, phosphate, H3, because it's 3 minus, and this is positive 1, switching H3PO4, as well as sulfuric acid. Okay. Now, how can you differentiate between strong acid and weak acids? First, by electrical conductivity. Strong acid is more has more conducts electricity in a better way because it's fully ionized, while weak acid is a poor conductor, you can say that. Or by adding metal or metal carbonate, for example magnesium ribbon or magnesium carbonate, or by the adding universal indicator. So as we said over here, strong acid is from 0 to 3, so 0 to 2, so it's red. Weak acids will turn orange. Now, how can you differentiate between strong and weak base? By electrical conductivity, by adding universal indicator. Now, reaction with bases. With acids, first one, which is neutralization, the one we just explained over here, which is this one here. Neutralization, which is acid with bases, with alkalis, group 1 hydroxides and oxides, or with metal oxides. And with ammonium salts. So basically strong base, which is, for example, this is group 1 hydroxide with ammonium salts. Ammonium chloride makes salt, which is sodium chloride, water, and ammonia. So basically this is a rule, okay? So basically when you have a strong base or ammonium salts, you have to do this way. You first, for example, strong base such as NaOH, okay? With ammonium salts, you have to have 3 products. Product number 1, product number 2, and product number 3. Product number 1 should be water. Product number 3 should be ammonia. These are constant. Sometimes, okay, sometimes you can put a number here, okay? That's when balancing. However, right now, you just write water and ammonia. And then what you do is that you get the Na, and then you get the Cl. And you put NaCl as this product. And so currently, I just want to tell you something. We got H2. Where did we get this H2? We got this as a 1H, and we got 2 over here. So this is H. We got one from here. So this is H3. So now we have 2 H's, and this is an O. So H2O. So these are not over here. Now we have H3. So we got this H, and we need an N. So this is an N. So we don't have this part. The only parts left are Na and Cl. So we just write them over here. Okay, so we're gonna now do an example of 6 of them. Let's start with number 1, acid metal, forming salt and hydrogen. So for example, let's give any salt or metal at first. So here is iron with sulfuric acid, which is a strong acid. So we basically do this. First, we have hydrogen. So we take off the hydrogen as the first product, and this is a must product. And then you write down the left ones as FeSO4, and that's it. Number 2 is acid plus metal oxide. Acid, for example, acid, or let's write the metal first as well. Acid, metal oxide, NaOH, which is group 1 oxide, with hydrochloric acid, which is an acid as well, and it's a strong acid as well. So we first have 2 products, water and salt. Water, first H. Okay, so we have water as H2O. So first H, second H, 1O, plus the rest NaCl, sodium chloride. Number 2 is acid metal hydroxide with so this is metal hydroxide, I'm really sorry. Let's do acid with metal oxide. Okay, so metal oxide, for example, Mg oxide, which is group 2. It's a strong base 2, but it's not as strong as group 1. It's okay. With, for example, sulfuric acid as well. So what you get is, remember, 2 H's, 1 O. 2 H's, 1 O. You put the Mg, then the SO4 as well. Now what's left? We have the carbon dioxide stuff, acid with metal carbonate or acid with metal hydrogen carbonate. Let's do acid, the first one, which is acid. Sorry. Acid with metal carbonate. Okay. So basically, remember, we have 3 products to show: salt, water, and carbon dioxide. So you basically just write carbon dioxide and water. Take off the water, which is H2 and O from here. So now this is O2 only to make H2O. And then you get another O2 for this one, and this C for carbon dioxide. And now write the left products as the salt product, CuSO4, and this is 100% correct. Let's solve for acid with metal hydrogen carbonate. Acid, for example, acids such as, let's say, okay, as well, H2SO4, okay, or for example, let's say HCl, anything, okay, with metal, hydrogen, and carbonate. Yes, this way. So as we said, we have 3 products. Okay, product number 1 is water. Product number 2 is carbon dioxide. And product number 3 is the salt of the atom's remaining thingy. So basically H2O, H2, and then the O, this O, with this O, 3 O's, okay? Okay. With a C, C, and the red H2, basically the left atoms NaCl. Let's highlight them as well. And this is also correct. Now let's check if something is left. We have still acetic oxide and base. And now we have the ammonium salts. The neutralization, we're done with them. With ammonium salts, the same exact idea, which you put the strong base here, group 1 oxide, hydroxide, ammonium salts here, and then we have 3 products, salt, water, and ammonia. You put the water, then you put the ammonia. Exactly, you take the NH4 and the OH, 2 H's for water, 1 O for water, 1 H from here, so H3 is left with N for ammonia, and then NaCl for ammonium salts. This is the reaction table we just explained before as well. The basic oxide reacts with acid, but never react with base as well. Acidic never react with acid, reacts with base only. Neutral never react with anyone. And photaric, for example, aluminium oxide and zinc oxide react with both. And basically over here we have the salt preparation. So we have 4 types. Acid with alkali, which gives salt with water, which is the only titration method. Then the rest are excess methods. Here's the titration method. You first prepare the alkali, which is sodium chloride from hydrochloric acid and sodium hydroxide. So basically this is the alkali, and this is the alkali, this is the acid, and this is the salt. You put with the pipette 25 centimeter cube of sodium hydroxide, which is the alkali, in a conical flask with 4 drops of phenolphthalein indicator. Anyway, this is the indicator used over here. And then you add hydrochloric acid until color changes from pink to colorless. Just add until the color changes from pink to colorless. Then record the volume of acid added. Now repeat. Best repeat it without the indicator, no indicator. And then put it in the evaporating dish. Evaporate the salt solution in a steam bath until the crystallization point. Then remove the heat and let it cool. Now filter crystals formed and dry them between 2 pieces of tissues. This is the titration method, acid with alkali. Now let's see the other 2 methods we have. We have 2 other methods. One is called excess method and the other one is called precipitation method. Let's start with precipitation as it's very easy. So basically as it's very easy. Now, first, the precipitate is an insoluble salt formed when 2 solutions are mixed. So that's why we make precipitation. So first, you put, if you want to work out if precipitate is formed, you work here, okay, you put barium chloride with sodium sulfate, for example. Then, we form sodium chloride and barium sulfate, and this is called direct partner swapping. So basically, that's why it's called direct barium chloride, barium swapping. You have barium chloride and you have sodium sulfate. Basically, you put barium with sulfate, the first with the second of this one, and here the first with the second of this. No, it's not like this, but it's like the first with the second, and here the first with the second. Okay, so when you put the first with the second, you make barium sulfate, and when you put the first with the second, you make sodium chloride. Okay, this is not balanced. This is not balanced, and symbols are not correct. For example, Na. Okay, continue. So here sodium chloride is soluble and no precipitate is found. However, barium sulfate is insoluble and yes, there is precipitate. So basically, after you do this part, you have to look up your solubility table to see if the two salts produced are soluble or insoluble. We found out that this is soluble and this is insoluble. I'm going to show you the solubility table at the end of the video. Not at the very end. No, it's at the very end of this video. Okay, not very, but okay. So now let's see. You put 1 centimeter cube of each solution to a test tube. Then you filter the precipitate. What you do, you filter the precipitate. Now you wash the precipitate by pouring little distilled water through it before the filter paper is taken out of the funnel to remove any of the solution of soluble material to leave precipitate alone. Now dry the residue in a warm oven or a desiccator. That's it. Let's now study the excess method. You know that you normally can produce salts by simply adding an excess metal to acid, okay? But you have to provide the metal will react and then evaporate and crystallize the solution. However, you cannot do this in case of copper because copper does not react with dilute acid as it's lower in the reactivity series with hydrogen. So basically, excess method is, for example, with copper, as it doesn't react with dilute hydrochloric acid because it is lower than hydrogen in the reactivity series. And so, to prepare the salt solution, we have to react a copper oxide, for example, or a copper carbonate to make copper sulfate. So now let me tell you how we do this. So, you add an excess of copper carbonate, for example, or copper oxide, whatever we used here, copper oxide. So you first add an excess of copper oxide to 25 centimeter cube of sulfuric acid. Why we used sulfuric acid? Because we said we want to make copper sulfate. So as we want to make copper sulfate, we're going to use sulfuric acid. And then we're going to use copper oxide as copper does not react with hydrogen as it's lower in the reactivity series. So we neutralize all the acid by adding excess copper oxide to 25 centimeter cube of sulfuric acid. Now heat and stir the mixture together as much as of the solid to react. Now filter the solution to remove unreacted excess solid. The filtrate is then heated using a steam bath until crystallization point. The heat is removed and the evaporating basin left to cool. Any crystals are formed are filtered and dried between two pieces of tissues. And this is the excess method, which is the second method. So now we have three methods: titration, precipitation, and excess method. Now we're gonna have the solubility table. Here, the solubility table. So basically, okay. We have soluble, which is all group 1 salts and ammonium salts. Okay. And we also have all nitrates. We also have the halides. Halides, for example, chloride. How do I write that? Yeah, chloride, bromide, you know? Yes. And then we also have the sulfates. For halides and sulfates, we have a point to say. Just let me complete this part. And all group 1 ammonium, group 1 and ammonium carbonates, we also have a point to say in this one. Basically, because insoluble for halides, let us color this in black as well, like this way. So in halides, except silver and lead halides. Okay, for sulfates, except calcium, barium, and lead sulfates. For ammonium carbonates, ammonium carbonates are soluble, but all other carbonates are insoluble. But all other carbonates are insoluble. We also have the color of salt formed. So basically, or the color of salt. So basically, let's do this part. Color of salt. And here, the cation present. So white solids and forms colorless solution are basically, let's go, potassium, calcium, sodium, magnesium, aluminium, barium. This is barium, sorry. Yes. Lead. Okay. Yes. Sorry. Zinc and ammonium. I'm really sorry. So here, pale green. We have iron 2, because yellow brown, we have iron 3. We also have green. Here we have green, here we have pale green. Okay. In green we have nickel 2 plus and chromium 3 positive. Last one, which is blue to pale green, or like, this slash. It depends on compound. It's copper 2 positive. That's all for this video, or for this part currently. So don't forget to subscribe and like and do whatever you would like to do for this channel. This is its name on, this is the account's name on Instagram, and as well as on YouTube. I don't like this color. Okay. Thank you.